Okay, Bismillahirrahmanirrahim. Assalamualaikum and good morning. Today our group will present our project about EEV engine vehicle. So for the main topic is fuel cell. Our group members, first one is Muhammad Izzuddin bin Muhammad Syahidi. Number 2, Muhammad Hilmi Rashidan bin Muhammad Rashid. Number 3, myself, Muhammad Akib Baruslai. Number 4, Muhammad Fidaus bin Nasripan. Okay, next. Okay, for the introduction, I will explain about the background. Okay, in efforts to reduce greenhouse gases, which is GHG, generated by air pollution, gases which is it can cause climate change. So the green technology was introduced. The electric vehicle, which is EV, is a product in development that is expected to contribute to pollution reduction. So together with sustainable power plants such as hydro, wind, nuclear and solar power plants, EV deployment can effectively keep clean air on the road, directly increasing air quality. Okay, next. So for the objective of this project is to produce no harmful emissions in the air, to eliminating or decrease the costs associated in gasoline fuels, to make or create new products with zero emission, to create sustainable power source, and lastly to increase the lifetime of electric vehicle and improve performance. Next. For the scope of study, in this project, our group are being studied on the system, architecture, and also the main components of Hyundai and Toyota electric vehicles. And the second one is the working principles and the efficiency, also the fuel efficiency for Hyundai and Toyota electric vehicles. Okay, for selected type of engine technology, our group okay, in this project there is a lot of electric vehicles which is cause the scientific world to move forwards environmentally friendly energy sources. So our group decided to focus more on fuel cell vehicles, which is we are likely to study and elaborate more about this technology. Next. Okay, for methodology, I will pass this presentation to my friend.
Okay, Assalamualaikum. My name is Muhammad Rashidan bin Muhammad Rashid, and I will continue the presentation. First, we have the methodology. This is the project flow that we must follow that we do. As we can see, we started with the project start. We start with an introduction and then methodology. Third is literature review, discussion, conclusion, and reference. And lastly, we will submit the project. This project flow is very important to ensure that the project is carried out according to the project flow. Next slide. Okay, next we have a project Gantt chart. Project Gantt chart is important when implementing a project because the work process must be in accordance with the time period. As we can see, that we must follow. First, we must do a project outline that have introduction, methodology, intellectual review, discussion, completion, and recurrence. All of this must be done by following the week that just be agreed on the project Gantt chart. As we can see, it started with week 7, week 8, week 9, until to week 13. Next. Okay, for the team member job scope, Ahmad Hakim will be executed by, will do the introduction. For the methodology, will be executed by me, Muhammad Ibn Rashdan, and for the detailed lecture review will be by the Muhammad Firdaus, and for the discussion, conclusion, and reference will be executed by Muhammad Izzuddin. Next. Okay, as we can see, this is the difficulties and challenges during the project. First, many assignments at the same time. Second, slow internet access while surfing the internet for study purpose. And third is a true picture of the EEV engine technology of our choice when doing the project. Okay, next. For the lecture, pass the presentation to Muhammad Firdaus.
Okay, my name is Muhammad Firdaus bin Nasri Wan, and I will continue the presentation with the literature review. Okay, as we see in the slide, this is the fuel cell electric car example. In the slide, this is the Hyundai iX35 FCEV, which is production in since 2013. The car is powered by a fuel cell with the hydrogen. Hyundai indicate an output of 10 kilowatt or 136 PS and a torque of 300 Newton meter. A tank content of 5.64 kg of hydrogen and should last for a range of nearly 600 kilometers. Next. Okay, the second fuel cell electric car example is the Toyota Mirai. The Toyota Mirai is a mid-sized hydrogen fuel cell vehicle, or the FCV, that manufactured by the Toyota. Okay, next slide. Okay, this is the last fuel cell electric car that we take. This is the Hyundai Nexo. Hyundai Nexo is a hydrogen fuel cell power crossover SUV that was revealed in 2018. Okay, the Nexo has a 160 S and 400 Newton meter electric motor. The vehicle features 3 fuel tanks with a total capacity of 156 liter and 6.3 kilo sum of. Next. Okay, in this slide, okay, this is the system architecture and main component. Okay, the main component is the battery or the auxiliary, the battery pack, the DC or DC converter, electric traction motor or the FCEV, okay, fuel cell stack battery pack, fuel filler, and fuel tank or the hydrogen. Okay, as we can see at the picture, it show the where the component is located. Next slide. Okay, this is the working principle on how do hydrogen fuel cell work. Okay, a fuel cell needs a 3 main component to create the chemical reaction, which is the anode, cathode, and electrode. First, hydrogen fuel is channeled to the anode via flow field. Hydrogen atom become ionized or the strip of electron and now carry only a positive charge. Then oxygen enter the fuel cell at the cathode, where it combined with the electron returning from the electrical circuit and the ionized hydrogen atom. Okay, next, after the oxygen atom pick up the electron, it then travel through the electroid to combine with the hydrogen ion. The combination of oxygen and ionized hydrogen serve as the basis for the chemical reaction. Okay, reaction is then use the power for for the car to move. Okay, next slide. Okay, this is the range, charging, and efficient or the fuel consumption. Okay, this is the three of model car that we take. This is the Hyundai iX35 FCEV, which the range of it can go is around 369 miles or 594 kilometers. For the Toyota Mirai, it can go until 312 miles or the 502 kilometers. And the Hyundai Nexo, it can go until 354 miles or around 570 kilometers. Okay, next slide. Okay, this is the cost for the model price that we take for the example is the Toyota Mirai. The price is around 57,500 US dollar, or in Malaysia is around RM 2,000, 885. For the Hyundai Nexo, it costs at 59,435 US dollar, or in Malaysian ringgit is around 261,395 13 cent. And the Hyundai iX35 is priced at 77,300 US dollar, or in Malaysia is around RM 339,965.40 cent. This is Hyundai iX35 is the highest price for the model. Next. Okay. Also in the cost, this is the operation cost. We take back for the three model. It is the Toyota Mirai, Hyundai Nexo, and Hyundai iX35. With the formula that at the bottom table, as we see, a liter times 16.51 per kilo equal cost. Okay, 1 kilo equal 14.128 liter. This formula I take from the Kin compressed gas core. Okay, as we see the Toyota Mirai, the tank capacity is 122 liter, and it costs the tank is around 8.64 kilo, and it costs around 142.64 USD, and in Malaysian ringgit is 627.33 for the full tank hydrogen. And Hyundai Nexo, the tank capacity is 156 liter. For the cost of 156 liter to full is around 182.27 US dollar. In Malaysian, it costs RM 101 ringgit 0.62 cent for the fuel tank hydrogen. And lastly, the Hyundai iX35. The tank capacity is 152 liter. It costs for the 10.76 kilo is around 176.65 US dollar, and converted to Malaysian ringgit it around RM 781 ringgit 30 cent for the fuel tank of hydrogen. Okay, the statement from to Joint Agency Report 2019, page 17. It stated the average price of hydrogen for a light-duty fuel cell electric vehicle or the passenger car in California is around $16.51. or in Malaysian ringgit is 72 ringgit 61 per kilogram. Okay, next slide. Okay, I will give the presentation to my fellow friends.
Okay, Assalamualaikum. I am Muhammad Izzuddin bin Muhammad Syahidi to present about discussion and conclusion. Okay, for discussion, we have two little title. The first is advantage and disadvantage. Okay, for the advantage, I will explain first one by one. Okay, first is renewable and readily available. Perfect for our future zero carbon need for combined heat and power supplies. Second, hydrogen is a clean and flexible energy. Production, storage and use of hydrogen will play an important role in driving future development of renewable energy by balancing their intermittent supply modality with the challenging end use demands, avoiding the need for significant yearly investment to upgrade grid infrastructure. More powerful and energy efficient than fossil fuel. High pressure gases and liquid hydrogen have around 3 times the gravimetric energy density, around 120 mJ or kilogram of diesel and LNG, and a similar volumetric energy density to natural gas. Okay, the next is highly efficient when compared to other energy source. Conventional combustion-based power plant generates electricity at 33 to 35% efficiency compared to up to 95% for hydrogen fuel cells. Almost zero emission. Hydrogen fuel cell does not generate greenhouse gas emission as for fossil fuel source, thus reducing pollution and improving air quality as a result. Reduce carbon footprint. With almost no emission, hydrogen fuel cells do not release greenhouse gas, which means they do not have a carbon footprint while in use. Fast charging time. Hydrogen fuel cell can be recharged in under 5 minutes. No noise pollution. Hydrogen powered vehicles are much quieter than those that use conventional internal combustion engine. No visual pollution. Hydrogen fuel cells do not have the same space requirements, meaning that there is less visual pollution too. Long usage time. A hydrogen vehicle has the same range as those that use fossil fuel, around 300 miles. Ideal for use in remote areas. Where local conditions allow, the availability of hydrogen to local generation and storage could prove to be an alternative to diesel-based power and heating in remote areas. Versatilities of use. Hydrogen fuel cell will be able to provide energy for a range stationary and mobile application. Demonstration of power supply. Hydrogen fuel cells have a potential to reduce the dependency of nations on fossil fuel, which will help democratize energy and power supply around the world. Okay, the next is a disadvantage. The first is hydrogen extraction. Hydrogen does not exist on its own so need to be extracted from water via electrolysis or separate from carbon fossil fuels. Investment is required. Hydrogen fuel cells need investment to be developed to the point where they become a genuinely viable energy source. Cost of raw material. Precious metals such as platinum and iridium are typically required as catalysts in fuel cell and some type of water electrolyzer, which means that the initial cost of fuel cell and electrolyzer can be high. Regulator issue. Without clear regulatory framework to allow commercial projects to understand their cost and revenue basic, commercial projects can struggle to reach a financial investment discussion, or the simple words is FID. Next is overall cost. The expenses also impact cost future down the line, such as with the price of hydrogen-operated vehicle, making widespread adoption unlikely at the moment. Okay, hydrogen storage. Storage and transportation of hydrogen is more complex than that required for fossil fuel. Infrastructure. Large-scale adoption of hydrogen fuel cell technology for automotive application will require new refueling infrastructure to support it. Although, for long-range applications such as those for HGV and delivery truck, is it likely the start-to-end refueling will be used. Highly flammable. Hydrogen is a highly flammable fuel source, which brings under stable safety concern. Hydrogen gas burn in air at concentration ranging from 4 to 75%. Okay, next is a future prospect. For the future prospect, the weakness of the fuel cell electric vehicle will be improved with several functions and other features such as the tank for hydrogen enlarged. All hydrogen stations will also be improved for the conversion of vehicles that use the fuel cell electric vehicle, and cost for manufacturing can be reduced with complex and simple innovation. In turn, for the use of chemistry that is hydrogen, the material used need to be improved to get a longer distance traveled and have a good performance in each trip. Okay, the last is conclusion. In conclusion, fuel cell electric vehicle is very important for every customer who want something different that has features that are other than other electric vehicles. Fuel cell electric vehicle also has a good effect for daily use and easy to charge in less than 5 minutes. That's all for my group team. Thank you.